Hello everybody, we are in the 17th class and this is where we discuss the multiplexer, second part of the multiplexer. In the last class we had seen the basic concept of multiplexer, and in this particular class we shall look at some practical ICs, integrated circuits, which are used for multiplexing operation, and we shall look into how they are developed and how they work. So, this class will be mostly on the practical use of multiplexer in your lab or any project or any design activity that you plan, how you take the go for the hardware implementation. So, in the first slide we discuss IC 74153. Okay. So, in this particular IC we see a 4-to-1 multiplexer. So, 4-to-1 multiplexer, the basic concept we have already seen, we had seen in the last class. Okay. But when you practically implement it, you see in this particular IC there are 16 pins. This is 1 to 8 and 9 to 16, and this is how the circuit is made up of. So, in this circuit if you look at it, I will discuss it with all the inputs and other things. So, first thing you can see there is one 4-to-1 multiplexer over here. This is one 4-to-1 multiplexer that you can see. There are some other additional inputs we shall discuss later. So, this is another 4-to-1 multiplexer that we can see. So, basically this is a dual, that means two 4-to-1 multiplexer is there. The other thing that we can see is that the select input B and A, it is termed as B and A. So, this is common for both the units, this multiplexer and this multiplexer, select input is common. Okay? That is what we can see. And the third thing we see that each of these multiplexer has two separate input, one called strobe G1, another, this is another strobe G2. So, this G1 you see is connected, you can see from here to here. So, this strobe is not getting connected to this place, this strobe G2 is connected to this 4. Okay. So, the strobe part is individual. So, this strobe is affecting only this 4-to-1 multiplexer, and this strobe is affecting only the bottom 4-to-1 multiplexer. This is what we can visualize. Okay. Now, we look at how this particular circuit works, this practical circuit which is there in the form of integrated chip IC. So, integrated circuit we shall see how it works. So, when strobe is high, so there is an inverter over there, it is actually is a NOT operation that is happening. Okay. So, this output is 0. If strobe is high 1, this output is 0. So, if this is 0 for all the AND gates, the output will be 0, each of them the output is 0. So, the final output Y1 will be what? 0 only, that is low, irrespective of whatever is the value of BA, and these are the data inputs, whatever will be the value, okay, the output will be low. So, that is what you see over here. When strobe is high, the output is low irrespective of, XX means do not care, the value of B and A. This is happening for the bottom one also. If this strobe over here is high, then this output will be low. So, this is symmetrical. Okay. Fine. So, for normal multiplexing operation, the strobe need to be at low. Okay. Then this is high AND gate. So, the operation goes to the other inputs. Now, let us just take one particular example. So, if the select input is say 0 0. Okay. So, then this is 1 and this is 1. So, this one is connected over here to this AND gate. This one goes to this AND gate. I have shown you the line, right. So, this is the other input. So, these 3 inputs are 1 now. So, this AND gate output now will be whatever is 1 C0, that is the data input. So, 1 here means first block, this is a dual package, C0 is the D0 equivalent of what we had seen in the last class. Okay. So, this is the data input. So, this is what when you will get 1C 0 over here. And for all the other AND gates, you will see these select inputs, these are connected in such a manner that one of them is 0. Okay? So, one of them 0 means irrespective of whatever the data inputs are, each of these are 0, right. So, what will be the output then? Is 1C 0. Okay. So, when this is low, right, and these two are low and low, then the output is this C0 is the output over here. Similarly, over here in the bottom place also. When this is low and high, it will be C1, high low, this is C2 and this is C3. This is nothing but the multiplexing operation. So, additional thing over what we discussed in the last class, you see is the presence of the strobe, which is nothing but a enable like control input, that when strobe is high, the multiplexer is disabled, when strobe is low, the normal multiplexing operation is taking place. And we can have the corresponding equation over here. So, you can see if E is equal to 0, E is your strobe or enable. So, if E is equal to 0, okay, then this is 1 and normal multiplexing equation is there, and when E is equal to 1, so this is 0, rest of the thing is 0. So, this is clear. So, nothing to be scared like what is this circuit looks like, it is nothing but 4 to 1 multiplexer with additional enable input. That enable input is going to the AND gates, each one of them, and making it operational, the normal multiplexing operation for a specific value, and other value it is a fixed logic low, it is holding at the output. Okay. So, if this is clear, so we look at another circuit, multiplexer circuit, which is there, where the output is inverted. Earlier we have seen all the output is just whatever is the input, output is following the input. Okay. So, y is equal to d0, d1 and so on and so forth. So, here is a circuit IC 74150, this is a 16 to 1 multiplexer, right. So, it also has got a strobe input. So, strobe now we understand, no problem. So, whenever the strobe is high, irrespective of the others what is there in the select input, output is high. Why output is high? You see, this is AND gate and this is the OR gate. After that there is a inverter. Okay. So, in the earlier example we had seen that if this is high, so this will be 0, all of them will be 0. So, the output will be 0, right. But because of the presence of the inverter, now we see the output is high. Okay. This is clear. So, only when the strobe is or the enable is low, the normal multiplexing operation is taking place. So, low, 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 so all these things are low, then E0 will go to the output, right. E0 will go to the output. So, y will be E0 if this bubble is not there, inverter is not there. Since this inverter is present, y will be E0 bar, y will be E0 bar. Similarly, for other cases, E1 bar, E2 bar, E3 bar and so on and so forth. Okay. So, in earlier cases examples, we had considered this input to be D0, D1 data input. So, previous IC chip you have seen that was used as C0, and here the manufacturer, the data sheet, they are representing it as E0, E1, E2, E3, but the meaning remains the same. Is it clear? So, this is what we can see, and corresponding then equation becomes what? This is the basic equation we had seen, which we had seen before with enable. Okay. Now, because of the presence of this inverter, the whole thing, after that there is a inverter connected. Okay. So, this is what becomes the equation and the corresponding logic circuit. Simple. Now, we look at realization of certain truth table using the multiplexer, right. So, earlier we had seen in the last class that this is possible using Shannon's expansion theorem and all, right. Here we are taking some practical IC and looking at its realization. So, in this case we are looking at IC 74153, the 4 to 1 multiplexer we had seen before with a strobe or enable input. So, that is the basic equation of that, okay. And we want to realize a truth table which is something like this, okay. So, this truth table F00, whenever these two values are 00, it is 0, 0, 1, 1, 101 and 11, this is 0. So, this is the corresponding logic equation, basic logic equation. So, this we can write in terms of all the min terms b prime a prime dot 0, okay, b prime a prime ANDed with 0, b prime a ANDed with 1, b a prime ANDed with 1 and b a ANDed with 0. So, this looks like a multiplexer equation with d naught is equal to 0, d1 is equal to 1, d2 is equal to 1 and d3 is equal to 0, isn't it, right? And in the 74153 context, these are C naught, C1, C2, C3. So, C naught is 0, C1 is 1, C2 is 1 and C3 is 0, okay, C naught, C1, C2 and C3, right. So, what we do? We take only half the top part of the IC 74153 or bottom part, one part of it, right. B and A we connect the way, just the input is connected, right. We put E is equal to 0 or the strobe is equal to 0. If we are taking the top part, then the top part of the strobe G1 we take 0 and the corresponding 1C0, 1C1, 1C0, 1C1, 1C2, 1C3 we put as 0, 1, 1, 0 and we take from 1i the y1 the first part and this particular truth table is realized. Is it clear? So, that was for a 2 variable realization. So, for a 3 variable realization we can look at IC 74151 which is a 8 to 1 multiplexer. So, 8 to 1 multiplexer, it also has got a strobe input, okay, similar to that, and but it has got both non-inverted and inverted output. We have seen non-inverted output for IC 74153 and we have seen inverted output for IC 74150. So, IC 7415 has got both the versions. So, basically you can use any one of them depending on your requirement. And we want to realize a truth table which has got this min terms 0, 2, 3, 6, 7. Okay. So, how do you go about? So, this is the 8 to 1 multiplexer, these are the select inputs and we know 0, 0, 0, 0, 0, 1 up to 1, 1, 1, these are the corresponding data inputs. And going by the previous discussion in the earlier class and just now what we had done for 4 to 1 multiplexer 2 variable example. So, wherever these min terms are existing corresponding d naught value, di value, okay, we put them as 1. So, 0 is there. So, d in place of d naught we will put 1, then 1 is not there, min term 1 is not present. So, in place of d1 we shall put 0. So, accordingly 0, 2, 3, 6, 7. So, 0, 2, 3, 6, 7 we put 1 and rest of the places we put 0 and we take the output from the non-inverted output and the function is realized. Is it clear? So, this is the way it can be realized by the ICs in hand, and because of this we can find that multiplexer can be used as a universal logic circuit. What does it mean? It means that any logic function can be realized using a multiplexer by appropriately placing the input values, the data input values appropriately placing. Just it is a how you arrange the place the zeros and ones at the input side, you get the logic function realized. So, you have to just expand the logic function, Boolean equation in terms of where all the min terms are present, and accordingly you will place the inputs. Okay. So, this is a 4 variable example, and if it is a 4 variable example, what shall we use? We shall use 74150, okay, which is a 16 to 1 multiplexer. So, in this 16 to 1 multiplexer, one thing we need to take note of for IC 74150, that this is giving a inverted output. Okay, this is giving a inverted output. So, to realize what we can do, let us see one example. So, this is the basic equation of IC 74150 which we have seen before. Okay. So, this is the inversion that we are talking about, right. And so, first of all we put E is equal to 0. okay, that enable, otherwise the multiplexing operation will not be there. So, this is the strobe, and the truth table that we want to realize is this is the truth table that we want to realize. Okay. So, we give select inputs A, B, C, D over here like this, these are the corresponding pin numbers, right, and this truth table in terms of min terms. So, this is how you write 0, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 15. Okay. Now, if y is this particular function over here, this is prime, then y prime is what you get over here. You take prime inversion in the both sides. So, this is your y prime, okay, and this is the basic multiplexer equation. So, this is, if you are trying to realize these as y, what is the corresponding y prime? Y prime is the terms that are not included here, the max terms, these are the min terms. Okay. So, y prime, if you write in terms of the terms that are left over, is 1 over here, 6 over here, 7 over here, and 14 over there. Okay. So, y is like this. So, y prime is this one. Is it fine? So, in this case, since it is generating y prime by this equation, so what you need to connect? So, 1, 6, 7, 14. So, 1, D1, D6, D7 and D14 you connect to high, logic high, okay, and rest you connect to ground. Is it clear? Otherwise, you would have needed, if you go by the normal thing that 0, 2, 3, 4, 5 you put connected to 1, then you have to put another inverter after this. Okay. But it is equivalent truth table is y prime is wherever 1 is there, that is there is a 0, and wherever 0 is there, there is a 1. So, you can realize y prime, that is equivalent to get realizing y, the same truth table. Okay. So, this is what you can do when you have got inverted output. Okay. So, you can make a judicious decision, and that will reduce your hardware and all. Now, so far we have seen that as many number of variables for realization, as many number of control input or select inputs will be required. Okay. But if you have got a problem where you want to realize a 3 variable function, but you have got only 4-to-1 multiplexer available with you, can you go ahead? It is possible if we utilize the concept of entered variable, which we had done in earlier case where entered variable map based minimization and all. Okay. So, let us look at how this can be done through an example. So, this is one particular truth table that we want to realize. Okay. So, 1, 0, these are the terms, min terms which is present, and accordingly if it is 8-to-1 multiplexer based realization, it is very simple, wherever 0, 0, 0, this is 1. So, this is a 1 present, and we are just following this over here, and the circuit is realized. It is as simple as that, using 8-to-1 multiplexer. Now, since 8-to-1 multiplexer is not present, we have got only 4-to-1 multiplexer. So, we can look at combining the inputs the way we had done in case of entered variable map based minimization. So, if we consider C as the variable that will enter, so we form pair in this manner, right, if we recollect. So, here both A and B are 0, 0, right. So, when both A and B are 0, 0, we see that Y is just inverse prime of C. So, Y is C prime, and for other cases we see Y is equal to 1, Y is equal to 0 and Y is equal to 1, just if you take them as pair. Okay. How the output is there, output is not dependent on C other variable. So, only in this case it is dependent on C, but just as C prime. Okay. So, in the 4-to-1 multiplexer with AB as select input, now for 0, 1, this is the 0, 1 case, 1, 0 and 1, 1. These 3 cases we put 1, 0, 1 as you see over here, right, and for 0, 0 we put C prime. Okay. So, this also realizes the 3 variable function, but using a 4-to-1 multiplexer. Okay. So, this is the usefulness of this exercise, and this can be extended to uh, realization of 4 variable function using 8 to 1 multiplexer, just one order less, the way we had seen it before, how it happens for entered variable based minimization in a Karnaugh map. Similar thing we see that one order less is required for the multiplexer to be used for realization of the truth table. So, in this case there is another example where we have got 4 variable, the min terms are 0, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14. So, these are the min terms that we generate. Again we form pairs the way we had done it for the previous example. Okay. So, when ABC is 0, 0, 0, so 8 to 1 multiplexer means 3 select inputs will be there. So, output is just invert of D. Okay. And here the output, this is y is equal to D prime, this is y is equal to y is equal to 1. Okay. So, this is the way the rest of the things will be there. Okay. In the form of a table you can see what has been shown here. So, ABC is equal to 0, 0, 0, D is equal to 0 and D is equal to 1, these are the two cases. So, this is 1, this is 1, this is 0, this is 0. So, y is equal to just opposite of it. So, basically it is for 0 it is 1, 1 it is 0, so it is D prime. So, similarly you complete the rest of the things, you will see that y is equal to D prime over here 1, 1, 0, 1, 1, 1 and this is D. Okay. So, then your corresponding realization using IC 74151 with enable as 0, okay, and we are taking these non-inverting output. Then for 0 you are putting D prime, so this is D prime, and for 7 over here ABC 111 you are putting D, okay, D7 as D, and rest of the cases you are putting zeros and ones as per the requirement. So, 3 is equal to D3 is equal to 0 and rest of the D1, D2, D4, D5 and D6 they are 1 and the circuit is realized. Okay. Truth table is realized. So, that is how this multiplexer is very useful in and used as a universal logic circuit. Now, we shall look at some aspect of a practical multiplexer IC, which is 74157. Okay. So, this is 74157. If I ask you how many multiplexer is there and what is the type, then you can see first of all how will you investigate this circuit. So, one is strobe. At the input side you can see which is there common to all of them. So, if strobe is here it is low, high, then it is low. So, all of them will be, the output will be 0. Okay. So, when strobe is low, then only the normal multiplexing operation is there. So, that is what we have studied before and we understand it. The other thing that we see that there is only one select input. Okay. So, one select input. So, this is with one select input we can get 2 to 1 multiplexer, right, fine, and we can see that there is one block over here, there is another block over here, there is another block over here and there is another block over here. So, 4 2 to 1 multiplexer is there. Okay. So, this is called quad. Okay. 4 is quad. So, earlier we had seen dual, this is a quad. So, this 4 2 to 1 multiplexer is there with one common select and common strobe, right. So, if I write in the form of a logic circuit for a better understanding, so this is what you can see. So, this is A1, A2, A3, A4, okay. In the this is the as far as the manufacturer's data sheet. What we are representing this here as the same thing as A3 to A0 for certain reason which I shall tell later. So, similarly B1 to B4 we are representing exactly the same thing B2 to B0. I mean basically the same inputs, just designation is different. Okay. And when select is 0, this set is selected. So, basically this is AND OR. AND OR is also your NAND operation. So, that we have seen before, okay, in earlier weeks. So, meaning remains the same. SOP realization using AND OR and. So this is an alternate representation of the same circuit. Okay. So what we see here is that when select is 0, this y naught, y3 to naught becomes a3 to naught. This is when select is 0, and when select is 1, then y3 naught becomes b3 to 0. Is it fine? Okay. So this selection of 4 such bits as a whole, so this 4 bit as a group is called nibble. Okay. So this is also known as nibble multiplexer, and this has got its usefulness. Say we are talking about, we shall see later in more greater detail, say binary coded decimal. Okay. So a decimal number, say 7. Okay, we want to code it in binary. How we will do it? 0, 1, 1, 1. Okay, so this is the 0th bit, first bit, second bit, and third bit. So there is certain weight associated. More of that we shall discuss later in the subsequent weeks. Okay, and if we represent 9, what is 9? 1, 0, 0, 1. Okay, so these are the way they are represented. So if we want to output one of these two numbers depending on certain condition being fulfilled, say either 7 or 9, right. So we need a group of 4 bits. So these 4 bits are coming as a whole, either 7 will come or 9 will come, and accordingly there will be some display and other things. More of that we can discuss later. So this is what is done, and this is can be done through nibble multiplexer. So 4 bit can be selected simultaneously. If we require more than 4 bits, then we have to cascade it. We have to have another such unit there. So this is the corresponding circuit you can see. So now at times this nibble multiplexer is connected in a manner where many such units are trying to place data. So this is one block, this is one nibble multiplexer, this is another nibble multiplexer, right, and they are trying to place data over a common line depending on which one is getting selected. So if this is selected, that is the strobe is there, right, and the other I mean all these cases. So corresponding depending on the value, one of the two set of inputs will go there. Okay, right. Now if one common line is there in which all of them are trying to send data, then the data might get corrupted, because if out of these 4 lines one is sending 1, another is at that time is sending say 0, there is a problem. So when one is sending, the other one must not send. Okay. So and not only that, it must not also take any value, take any electrical energy from this particular circuit. So it should remain electrically insulated. So this is known as high impedance. So this is, we have seen discussed before, this is also achieved by a tri-stated output. So this tri-stated output is useful whenever we are talking about sending or grouping multiple bits and sending from one place to another. It is more important in that context. So in this case, IC 74257, earlier we had seen IC 74157 is a nibble multiplexer. Okay. So IC 74257 is also a nibble multiplexer, but now we have got an additional input over here, which is output enable. Okay. So this output enable is, what does it do? It is just tri-stating the output. That means if this is not, if this is high, then irrespective of what is selected and all, output will be at high impedance. So neither it will send anything nor it will take anything from the external world it is connected to, external electrical circuitry it is connected to. Okay. Only when it is low, okay, the output will be following the basic multiplexing operation. So nibble as a nibble multiplexer. So this is different from the strobe thing, which you need to understand. Okay, strobe, what does it do? Output will be all high or all low depending on how it is connected. Output is inverted or non-inverted, but it is having some value. It is not high impedance, and that might corrupt the data over here if it is having a common bus kind of architecture, right? But in tri-stated, okay, this is only a high impedance case. So this is something which we take note of. Okay. So with this we complete the discussion on multiplexer. Very quickly, what we have seen that output is held at high or low depending on output is inverted, non-inverted, by when the strobe or enable control input of the multiplexer chip is not activated, and when it is activated, normal multiplexing operation takes place. A multiplexer can be used as a universal logic circuit, okay, and a lower order multiplexer can be used where the concept of entered variable comes into picture, by which we can obtain a logic function, and multiplexer with tri-stated outputs has additional control input which, if not enabled, keep the output at high impedance, and enable multiplexer are useful when group based binary operations are done. Okay. Thank you.